Okay, so previously, we've split and shuffled our data and put everything into a data frame. Now let's create that sparse matrix. To do that, we will use three things. We will use our X-train data frame. We will use our Y-train pandas series. And we will also use our vocabulary words. Remember those? They look like this. Our vocabulary of 2,500 words is stored in a data frame where the index are the word IDs and the individual strings are in a column called vocab_word. Now, if we've got this data frame here and we want to know which word has word ID number 3, then we can find that really, really easily. And we've done this before because all you would have to specify is the index and the column. And then you'd get a string that reads email. But say we know the word and we want to know the word ID. Now we're asking this question in reverse. We're asking it the other way around. For example, what is the word ID for the string email? An easy way to answer this question with some Python code is to create an index from this column here, from the vocab word column, and then look up the position of a particular string in the index. Let me show you what I mean. I'll add a quick markdown cell here that reads, create a sparse matrix for the training data. Now, to turn a particular column of our data frame into an index, all we'd have to do is select our data frame, select the column, and then wrap that whole thing into some parentheses and put it inside pd.index. This will create an index from a particular column in a data frame. Let's store this in a variable called word_index. So word_index is equal to pd.index parentheses vocab.vocab_word. Now we know we're dealing with a index, with a pandas index, because the type of word_index is pandas.core.indexes.base.index. And this index is composed of strings, individual strings like HTTP, email, get, and so on, the ones we saw earlier. And I can verify this if I say pull up the, say, fourth word at index position number 3 and check the type of this word. And there you can see that indeed we're dealing with strings inside our index. If I come back up here and take a look at our first email here in our x_train data frame, I can see that it's probably the stemmed word for Thursday, right? THU. Now, if I wanted to know the word ID for THU in our word index, I can simply take our index and use the get_location method with THU passed in as an argument. And now I see that this word is at position number 395. So here's what we're going to do. We're going to take our x_train data frame and we'll take the information contained therein to create our sparse matrix. Let's walk through how we would do it with the first row that I've shown here. The document ID for this row is 4,844. We would be able to retrieve this information from our X-train using our index, since our document IDs are stored as the index values. Since 4,844 is the very first entry, the very first value in the index, we would be able to just say, give us the value of the index at position 0. That's what we can use to fill in our document ID of the sparse matrix. Now, what about the label? What about the category that this email belongs to? For that, we simply look towards the y_train pandas series. There, at the entry named 4844, we would either get a 1 or a 0. So this email actually is a non-spam email, so it would have the label 0. Now let's tackle that first stemmed word, THU, for Thursday. Here our word index comes into play. We can get the word ID for this string THU from our word index using that getLocation method. And as we saw earlier, THU is at position number 395. For that last column in the sparse matrix, we'll simply add a 1. And that's simply because we've counted one occurrence. In fact, on our first pass, we'll add 1 for all the occurrences. We'll combine the occurrences later. Let's move on to that next word, JUL, short for July. The document ID and the label, of course, stay the same, 4844 and non-spam. And then we simply, again, use our word index and get the location for this particular string. And this string has the word ID 494. And again, it occurs a single time. Now, because we've actually saved all our word IDs as a CSV file, we can actually verify the word IDs in Microsoft Excel or Google Sheets. If I double click on this file and I scroll down to, what do we say, position 494, then I see my stemmed word right here. Next up, it's that third word, rodent. So let's see what happens when we check whether the word rodent is part of our word index. If we do this, word underscore index dot get location, parentheses, single quotes, rodent, we will actually get an error. And that's because the word rodent doesn't occur frequently enough to have made it into our vocabulary. In other words, the word rodent will not be added to our sparse matrix. Instead, we move on to the next word. Our next word is in fact this one right here. Checking our index, we find that the word ID is 2386. This is essentially the workflow of how we will build up our sparse matrix. We're going to put all of this work into a loop and then wrap all of that into a function. So let's get on it. Here's what our function will look like. As always, we're going to start out with our def keyword, define, to create our function. We'll call this function make underscore sparse underscore matrix. A very imaginative name, but it's very clear. And I reckon this function should take 3 inputs. A data frame, an index for the word IDs, so let's call this one indexed underscore words. And then third, it should take in the labels, namely the Y values. So that'll be our third input. Put a colon at the end. And now we can add a quick description of what this function should do. 3 double quotes adds a docstring. And we'll provide a very, very quick description, right? Returns sparse matrix as data frame. And our inputs are going to be as follows. df is a data frame with words in the columns with a document ID as an index, parentheses, x train or x underscore test. Then the indexed underscore words parameter is going to be an index of words ordered by word ID. The labels should be the category as a series, in other words, y train or y underscore test. I think that'll do for a docstring. Now let's add the body of the function. Now, as you can see from the docstring, this function should work regardless of whether we feed in the x underscore train data frame or the x underscore test data frame. So let's capture the kind of dimensions of the data frame that is coming in as an input ahead of time. I'll create a variable called number of rows, and that'll be equal to the input df dot shape square brackets 0, and the number of columns nr underscore calls is going to be equal to df dot shape parentheses 1. So that's that. Now within the body of this function, I know that I'm going to be doing a lot of lookups. I'm going to be checking if the words in the data frame are part of our vocabulary list. There's a lot of checks that are going to be running as part of our loop. So I want to be working with a data structure called a Python set, as you recall. So I'll say word underscore set is equal to set parentheses indexed underscore words. Here I'm creating a Python set from our index that is being fed into this function as an argument. Now I'm going to add a nested loop. And within that loop, I'm going to be adding dictionaries to a Python list. Let me add the outline of this loop first. So I'll create my empty list first. I'll call it dict list and have 2 square brackets. And at the very end of our function, I'm going to return a pandas data frame that is going to be created from this list that we're going to be creating inside our loop. Now in between these 2 lines of code is going to go the meat of our code. There'll be 2 loops. For I in range parentheses number of rows. That'll be the outer loop. And then there'll be an inner loop for j in range number of columns. So we're going to go through this data frame that we're feeding in row by row and column by column. Within this inner loop, we're going to be appending a dictionary to our list every time the loop runs. Here's how it's going to work. The very first thing that we're going to do is we're going to get hold of a particular string, right? And by a particular string, I mean the value in a particular cell, because we're going to iterate through this data frame row by row and column by column. To get hold of a particular word, we'll say df dot I at square brackets I comma j. In other words, we'll be retrieving the word in the ith row and the jth column. Then we'll check if that word that we picked out of our data frame is in our word set. And if it is, then we should fetch the document ID, the word ID, and the category. The document ID is going to be equal to the value of the index in the ith row. So df dot index square brackets I. The word ID is going to be equal to the indexed words dot get location parentheses word. Word is a string. We can feed that into our getLocation method to retrieve the position of this word in our index of words, and that will be equal to our word ID. Now it's time to get the category. The category is going to be our Y values at the document ID, right? The Y values we said we'd feed in as this labels parameter here. So we'll say labels dot at square brackets doc ID. Now we've got the 3 things that we need. And from that, we can create a little dictionary to put them all into one data structure. And I'll call that item is equal to curly brackets, single quotes, label, colon, category, comma, single quotes, doc underscore ID, colon, doc underscore ID, comma, single quotes, occurrence, colon, 1, comma, single quotes, word underscore ID, colon, word ID. Here I've created a dictionary with 4 entries. The first one has the key label, and it gets the Y value, the category, spam or not spam. The second is our document ID, which will get the document ID that we've extracted here. The third is occurrence, which is always going to be equal to 1 because we're kind of doing a first pass on this. And every time we discover a word that's part of our vocabulary, we'll add it to our data frame. And the last one here is the word ID, which we've retrieved here. So now that we have a dictionary for a single item, what we can do is take our dict_list and append our item. So we're appending all our dictionaries that we're creating as this loop runs individually to our list, which initially starts off empty, but then gets populated, and the data frame that we're returning from this function gets created using this list. Fantastic. So here's the whole function body in its entirety. Let me press Shift Enter on this. And now let's try and run this baby. I'm going to scroll down here into this next cell. And the first thing I'll do is actually add some micro benchmarking code. So %% time. This will time how long this cell will take to run. Now I'm going to store the results of this function call, this data frame, in a variable called sparse underscore train underscore df, and I'll set that equal to make sparse matrix, and you guessed it, I'm going to give it the training data, right? X underscore train, comma, word index, comma, Y underscore train. And now let me hit Shift Enter and let's see what happens. Now this cell can take quite a long time to execute. It's parsing a lot of data, and it's going through another data frame that has thousands of cells and thousands of columns in it, and it's going through it one entry at a time. On the machine that I'm currently on, this cell takes between 5 to 10 minutes to run actually. So I typically step away and grab a croissant or a coffee or something, and I come back when it's done. And I really encourage you to do the same. There's no point in waiting around. This is actually one of those times where you'll see a dramatic performance difference, whether or not you're using a set data structure or not. This check here in our inner loop runs thousands of times. So any minimal difference in time that this lookup, this check takes, you'll actually see that build up to quite a significant amount of time. If we go back up to our constants, then you'll spot another thing that really determines the size of the data set that we're working with. Yes, we imported approximately 5,800 emails that we're parsing and so on. But one of the key inputs, one of the key constraints that we set is actually our vocabulary size. We set this at 2,500. And this vocabulary size will actually determine how big of a matrix we end up with at the end. The reason I picked 2,500 is because it's relatively large. It's going to make our computer work quite hard, but it's nowhere near sort of a commercial application spam filter for a naive Bayes model. If we were, I don't know, operating Hotmail or Gmail or something, and we had to build this naive Bayes classifier, we would typically set our vocabulary size at 10,000 to 50,000 words. And you can imagine how much data we would have to crunch and how long we would have to run our machines for. All right, pretty chuffed to see that it's all done now at 6 minutes and 28 seconds. This means that we can take a look at the results, see if they make sense. Let's take a look at the first 5 rows here. So sparse train underscore df square brackets colon 5 will give me the first 5 rows. And here I can see my word IDs. Each of these words occurs only once, and all of these words occur in email number 4844, which is a non-spam email. Let's take a look at the shape of this data frame now. So sparse underscore train underscore df dot shape, shift enter, shows us that we've got approximately 450,000 rows in this data frame. That's an absolutely huge amount, almost 500,000. This is one of the reasons why this whole thing took a good 6 minutes to run on my machine. The last 5 rows of this data frame look like this: sparse underscore train underscore df, square brackets, minus 5, colon, closing square brackets. Here you go. All of these rows pertain to email number 860. Now, one of the reasons why there are 450,000 rows in this data frame is because we've put each and every single word from x underscore train into a separate row. So if in the same email we have the word Thursday occur twice, it has 2 separate rows in this data frame. What we're going to do now is we're going to combine these occurrences, right? If a word occurs more than one time in the same email, we should combine it in this data frame. We should have an occurrence of 2 for this particular word ID.